Alright, well, this is part 2 of the video. Okay, we are continuing work on our practice test here called Test E, all about circles and spheres. In part 1, the other video, we did all this work. Look at all that. We did number 1 through number 6. Alright, so if you need to see any of those, go back and look at part 1. But this video will cover the rest, number 7 through number 12. Okay, so let's check it out. These problems, children find this tricky. Students, I shouldn't say children, I'm sorry. Could be adults watching this. Find the shaded area, okay? That's the area between these two shapes. Now I'm hoping you can see when you look at this, when I talk about the two shapes, there's a big circle and then there's a small circle. So it's very much like this. If I can just demonstrate, you can imagine that this shape was created by starting with some big old circle like that. Alright, that's a big circle. And then there was a smaller circle that came along, you know, something like this. Okay, and that circle is blocking out or subtracting. You can think of it like scissors that are cutting out part of it. Alright, so think of it as a big circle, okay, and then minus, snip, okay, like I just punched a hole in it, and so I'm subtracting the smaller circle. Okay, so it's going to be the big circle minus the small circle. Okay, I might need this later, so maybe I'll save it off to the side. Just move it over there for now. Okay, so if I were you, every time we do these problems, you should make a diagram showing your plan. Sometimes I might give you points just for the plan. So we need to do the big circle minus the small circle. It's always the outer shape minus the inner shape. Now these are both circles, so in both cases we're going to be doing pi r squared. So we're going to be doing pi r squared minus another pi r squared. Obviously the r's are different. Now if you think one of these r's is going to be 8 and one of these r's is going to be 3, you are wrong twice, my friend. You are all turned around. So let's start with the small circle, just because I think that's the easiest. This 8, is that a radius? Oh no, my friend, you were sadly mistaken. Radius goes from the center out to the edge. So that's the radius. So what is the radius of this small circle? Of course, that is 4. So this is going to be minus pi times 4 squared. Okay? So that's the area of the small circle that we're subtracting. Now the area of the big circle. We need the radius of the big circle. Okay? Now remember, like look at this picture I drew over here. The radius of the big circle goes from the center all the way out to the edge. Okay? Let me move this for a second. See this little white thing? The white circle does not change the fact that the radius goes from the center all the way to the edge. Okay? So, when we look at this big circle, we need to be looking for how far is it from the center all the way to the edge, all the way. Now, if you understand that this piece right here is 4, like we just discussed. Alright, that's the radius of the small circle. And then this piece up here is 3. Just from here to here. That's not the whole thing, that's just one part. So that tells us that the whole radius must be 7. 3 plus 4. So that's why this is going to be pi 7 squared. Okay, 7 squared is 49, so this is going to be 49 pi minus 4 squared is 16, so that's minus 16 pi. For an exact answer, am I done? Do I leave it like this? No, these are like terms. 49 pi minus 16 pi. They both have pi's. Okay, 49 pi minus 16 pi. Well, it's really going to be a matter of just doing 49 minus 16. So that's going to be, what, 33? So we get 33 pi. Don't forget the pi. So 33 pi, ladies and gentlemen. We are talking about area. So this should be meters squared. That's just the units. But 33 pi is the answer, the exact answer. Or we could put it as a decimal by hitting that toggle key. So that is 103.68 square meters. Alright, and that's what it would be in decimal form. In decimal form, I always want 2 decimals. Do not round until the very last step. Okay, now let's do number 8, which I covered up. I need to fix that. So, get rid of all this garbage. Okay, here's number 8. Man, kids have trouble with this. Students, adults even, have trouble with this. I don't want to discriminate. We have 2 shapes here. I'm hoping you can see that the outer shape is a circle. So we're going to be doing circle minus, and then the inner shape is a square. So we will do circle minus square. So when we do the area of a circle, we will be doing pi r squared. When we do the area of this square, we're going to be doing base times height, because that's how you find the area of a square. So let's start with Mr. Circle. We need the radius to find this. So the radius goes from the center of the circle out to the edge. So this 9 meters here, that is the radius. So I can use that. So that makes this pi times 9 squared, which is 81 pi, by the way. Maybe I'll go ahead and write that down also. 81 pi, because 9 squared. Now, this is the part that takes a little bit more thought. We need to find the base and the height of this guy. Now, the way I taught you to do this is go ahead and look at the fact that this is a 45, 90 triangle. If you go ahead and draw the whole diameter. What I have is a isosceles right triangle. Remember, this 9, that was the radius. So guess what? What is the diameter? Oh yes, you guessed it, because you're really, really smart. This is going to be 18 meters. Alright, let's focus on the 18. So, this is the hypotenuse of my right triangle. So you have to remember how the relationships worked if you had a 45 right triangle. The sides were both the same, so it would be like leg, but then the hypotenuse was always leg radical 2. Okay, so see this x radical 2? That's sitting here where the hypotenuse is. So I'm going to take that x radical 2, and see the 18 is in the same spot as my x radical 2 was in the other picture. So what I'm going to do is I'm going to make a little equation out of it. So that means I better use like purple. Okay. No, I'm going to go red. Okay, x radical 2 must equal that 18, because the x radical 2 is the hypotenuse and the 18 is the hypotenuse. So they must equal each other. Remember that this x, when I find it, x represents the sides of the triangle, the legs. So if I find this x right here, that's going to give me the sides of the triangle. So if I want to do that, all I need to do is divide by radical 2. on both sides. That way these radical 2's go away. 18 divided by radical 2 looks like this. 18 over radical 2. I get 9 radical 2. Okay, so that tells me that x is 9 radical 2. Now remember, that x I just found, that's the sides of the triangle. So that means that this is 9 radical 2 right here. I need to do a different color. I'm going to try orange, maybe. I'll try this color. Okay, so look, this is 9 radical 2 right here. And this is 9 radical 2 over here. Now, what was the point of all that, you say? Wow, that's a terrible 9 radical 2. One more time. We're trying to find the area of the square. We needed the base and the height. So the point of doing this whole 45, 45, 90 triangle thing was to figure out that these are 9 radical 2. So now, when I go to do my base times height, I can do 9 radical 2 times 9 radical 2. So let's put that in your calculator. Okay, 9 radical 2 times, whoa, fail, times 9 radical 2. That gives me 162. So that's 81 pi minus 100 and, whoa, 162. And this does not have a pi on it, and this does. So that is as far as we can go as far as exact answers go. So this is the exact answer right there. Or you could put this as a decimal. So what's 81 pi minus 162? So 81 pi minus 162. Whoa. Oh, I put 18 pi. Wow. That was silly. Okay, let me try that again. 81 pi minus 162. That's better. It can't have you can't have negative answers, people. So 92.47. Okay, units, and this is area, so this will be meters squared. Alright, so that is how you do number 8. Okay, let's investigate number 9. Find the shaded area, the area between the cracks of all this. Let me zoom in a little bit more so we can really get a good look what's going on over here. Okay, we're given that this side of the square is 32. So that's good to know. If this is 32, look at each one of these, like this, and this, and this, and this. Okay, can you tell me what each one of these diameters is? Of course you can, because, alright, so if I just look at this one right here, there's 4 of them, and they all add up to 32. So if I take my 32 and divide it by 4, that's going to give me 8, right? So that tells me, alright, so 32 divided by 4, that's 8. So that gives me that these diameters, each one of these diameters are 8. You feel me? Alright, so this is like 8 8. Alright, this is bothering my OCD. I wanted to really make that red so it would match the red, but I don't have time for that. So these diameters are all 8, 8, 8, 8. Total of 32. Fine. Okay, but when we start dealing with the the outer shape minus the inner shape and all that, we're going to need the area, so we're going to need radius actually. So if these diameters are all 8, what about a radius? Okay, what about a radius? Well, that'll be 4. Should be half of the diameter. Okay, fine. So what if I want to find the area of these circles, like one of them? Do we know that area is pi r squared? So does that mean that the area is going to be pi times 4 squared, because that's the radius? So does that mean that this is going to be 4 squared is 16, so 16 pi? Is that going to be the area of one of these circles? Yes, it is. So that means each of these squares has an area of 16 pi. Alright, I'm not going to write this on all of them, I'm just making a point. Alright, every single one of these circles has an area of 16 pi. Now let's get to the big picture for a second. In fact, I better zoom out for a second. Just like we did for number 7, if I want to find the space between shapes, I'm going to have to do some subtracting. I need to take the outer shape and then subtract away the inner shape. So, like number 8, I did the circle minus the square, outer shape minus the inner shape. So we need to use the same strategy here, but what's the outer shape? Alright, can you see that the outer shape is a square? Now, what's the inner shape? Well, the inner shape is a bunch of circles. Okay, so I need to take the outer shape minus the inner shapes. So square minus a bunch of circles. Now, how many circles are there? 1, 2, 3, 4. 1, 2, 3, 4. This is 4 by 4. 4 groups of 4. So that's 16. So 16 circles. So now we are getting down to the end of this thing. Go ahead and make this a little bigger. The outer shape is a square. This square is 32 by 32. So the area of a square is base times height. So 32 times 32, that's 1024. Okay, so 1024. That's the area of the square. Now we need to subtract the area of all these circles. Now the area of one circle is 16 pi. Okay, how can I turn this into the area of all the circles? Well, there's 16 of them. So if I multiply this by 16, now I'm subtracting all of them. Now it was just a coincidence that the area happened to be 16 pi and then there were 16 circles. So just keep that straight in your mind. Okay, this 16 is because the radius was 4 and I had to square it, pi r squared. This 16 is because there are 16 circles. So I had to multiply by 16, so I have not just one circle, but all 16 of them. Anyway, what is 16 times 16? 256. So that means I will have 1024 minus 256 pi. So this would be the final answer, okay, in exact form. This is centimeters, and now we're doing area, so this would be, centimeters squared. Or you can make it into a decimal. Okay, so 1024 minus 256 pi. So 219.75. Okay, so that's what this would look like as a decimal. Alrighty then. Moving on to number 10. Find the surface area and the volume. Well, this is pretty easy because we're just using the formulas. Surface area, you know what, I'm going to do it down here. So the formula for surface area is 4 pi times the radius squared. This 15 is the diameter. Okay, that means that the radius is 15 over 2. Okay, that's not going to show up very well. I better go red. Okay, the radius is half of this. You know, most of you guys will probably be more comfortable if I say that it is 7.5. Okay, but that is the same thing as 15 over 2. Either way, I guess you'll get the same answer, but fractions and stuff, man. We'll see what happens. Okay, so anyway, I need to substitute this in for r. So the surface area is going to be 4 pi. Let's see what happens if I do the 7.5 squared. Okay, now I'm going to put this in my calculator without the pi for a second. So, you know, 4 times 7.5 squared. So 4 times 7.5 squared. Okay, that's a nice round number. So that's 225. Now I'm going to put the pi back in. So 4 times this was 225. You know, I think I'll squeeze it in here. So that's 225 pi. That is the surface area. So 225 pi, or $706.86. And we are talking about surface area, so this will be square inches. Now the volume. Let me switch colors. I'll go purple in this one. Okay, so the volume is 4/3 pi times the radius cubed. So this will be 4/3 pi times 7.5 cubed. All right, let me see what happens if I type this in without the pi. Okay, 4/3 pi, I'm not going to put the pi in for now, times the radius cubed. So that's 7.5. To do the third, whoops, I need my parentheses first. 7.5. To do the third power, I hit the caret and then 3. So that gives me 562.5. Now if I really wanted to be cute, I would toggle this and get this fraction. Anyway, 562.5 pi would be like an exact answer. Or, now it's time for the decimal. Alright, or we'll get this, 1,767.15. Okay, so that's what the answer would be. Okay, that is how you do number 10. Alright, what's up with this table, you guys? Number 11. Easy stuff, okay? What do we got here? We might need extra space to work this stuff out. I'll figure it out as I go. So, if I've got the radius and I need to find the circumference, I'm going to need space. Okay, what I'm going to do is create myself some space, first of all. Okay, this will be good for me. So if I want the circumference, I know that the circumference is 2 pi times the radius. So if I'm given the radius, I can just put it in. So that circumference is going to be 2 pi times 12. 2 times 12 is 24, so that's 24 pi. So my circumference is 24 pi. You could turn that, no, I started to say you can turn it into a decimal if you want, but the directions specifically say leave your answers in terms of pi. That means leave it like this with pi in your answer. Now let's go ahead and find the surface area. Alright, which is just a new formula. The surface area is 4 pi r squared. That means the surface area is going to be 4 pi times 12 squared. Let's see what the calculator does for that. 4 pi times 12 squared. 576 pi. That's what my calculator does with that. Okay, 576 pi. Yeah, that's what I thought. Okay, that's fine and dandy. And then we need to find the volume of the sphere. So that's just one more formula. Okay, that volume is 4/3 pi radius cubed. So that's going to be 4/3 pi times 12 cubed. Alright, let's give the calculator a try first. So 4/3 pi times the radius 12 to the third power. I had to use the caret to get the third power. 4/3 pi radius cubed. Calculator handles it nicely. 2,304 pi. So 2,304 pi. Okay, so that's how you do this whole table thing. Did I get the whole table? Yeah. So let's see about the next one. Now the next one we are given the circumference, and then we have to find everything else. Always find the radius as fast as you can, people. But if I give you the circumference, guess what? Start off with the circumference formula. Circumference equals 2 pi r. Since I gave you the circumference, go ahead and substitute that in. So that becomes 8 pi equals 2 pi r. And then you need to divide both sides by 2 pi. Like so. That way this cancels out. Even the pi's cancel out. So that's going to just leave us with a radius of 4. Okay, so that is 4 inches. Once you have the radius, you can find the other stuff just like we did on the previous problem. Alright, erase, erase. So we found that radius. So now if I want to find the surface area is 4 pi radius squared. Okay, so that's going to be 4 pi times 4 squared. That's 64 pi. Okay, similarly, I could find the volume. Okay, we know the volume is 4/3 pi radius cubed. So that's going to be 4/3 pi times 4 cubed. Okay, 4/3 pi times 4 to the third power. 256 pi over 3. Alright, again, on these problems you may not use a decimal. It says leave in terms of pi. So I better see pi in your answer. And I really don't want to see any decimals at all. Okay. Alright, let's do this next one. This time you are given the surface area. So that means you better start off with the surface area formula, 4 pi r squared. So of course we're going to take this surface area and put it in for S. So that's going to give us 49 pi is equal to 4 pi r squared. So we need to get the radius as fast as we can. So we need to divide both sides by 4 pi. Okay, that's all. This is going to cancel each other out. Even those pi's are going to cancel each other out. Now be careful. You're going to be tempted to make a decimal right now. Don't. Okay, so right now I have r squared equals. And I'm just going to leave this as 49 over 4. So it's time to take the square root of both sides, guys. So I do the square root. I could put this in my calculator, but I don't need to because these are both perfect squares. Square root of 49 is 7, and the square root of 4 is 2. So that is my radius. So my radius is 7 over 2. Okay, yes, that is 3.5. So I guess you could get away with that too, but I'm going to leave it as 7 over 2. So I have my radius. Now I can use that radius to find other stuff, like for example the circumference is next. Circumference is 2 pi times the radius. So that's 2 pi times 7 over 2. Okay, that turns out to be 7 pi. Okay, you can just put that in your calculator if you need to. Alright, so that is 7 pi. Now if I want the volume, alright, which is the last thing, volume is 4/3 pi times the radius cubed. But okay, remember my radius is 7 over 2. So let's see what my calculator does with this. Okay, so 4/3 pi. Now I'm going to have to put this 7 over 2 in parentheses, guys. 7 over 2. Alright, so I can cube it. So this is 4/3 pi radius cubed. 343 pi over 6. Alright, and this was inches. Wait, no. I messed up on the units. Okay, sorry. This one is feet. So this is a length, so this is feet. This is a length, so this is feet. This is a volume, so it'll be feet cubed. This is inches, so this will be inches squared, inches cubed. Alright, last one. This time we're given the volume. Alright, this is the last one on the table anyway. 288 pi. We are given the volume. So we have to start with volume. Okay, so we know that volume is 4/3 pi times the radius cubed. So since they're giving us the volume, we're going to take the volume and substitute it in for V. So that's going to make this 288 pi equals 4/3 pi times radius cubed. So this is all about typing it properly into your calculator. So to get r by itself, we need to divide both sides by 4/3 pi. 4/3 pi. So these are going to cancel each other out, and these will cancel out, and these pi's are going to cancel out. So in my calculator, I'm just going to put 288 over 4/3 without the pi's. 288 over 4/3. Okay, just like we had it on the paper. This turns out to be 216. So understand that that is r cubed that I've got so far. Okay. So r cubed is equal to 216. Now if I want to find out what r is, I'm going to have to take the cube root of both sides. Okay? Cube root, like this. And if I take the cube root of something to the third power, that's just going to give me r. So how do I put this in the calculator, you say? How do you do cube root on the TI-30XS multi-view? Well, I'm glad you asked that. If you want to do the cube root, you have to start by typing in the number 3. Do you see above the caret button where it says this x root? That means any root I want. Specifically whatever root I put first. So, but to get to the stuff over the buttons, I have to hit second and then caret, and that 3 I put becomes the root. And I needed to do 216, which turns out to be 6. Okay, so that means the radius is 6. Now that is one of the things we were supposed to find. Okay, we're supposed to find the radius, and we did. So the radius is 6, what are the units? Meters. Alright, and the rest is easy. Once we have the 6 meters, we will just plug it into the circumference formula, the surface area formula, and the volume formula. Alright, so just remember that the radius is 6, and everything is going to be okay. So if I want to do the circumference, we know that the circumference is 2 pi r. So that's going to be 2 pi times 6. So that's going to be 12 pi. Okay, meters. If I want to find the surface area, alright, the surface area is 4 pi times the radius squared. So that's going to be 4 pi times 6 squared. Alright, so that's going to be 4 pi times 36. And then 4 times 36 is 144. So that's going to be 144 pi. Okay, and we had volume to start with. So that is how you do that. Alright, I think we're down to the very last problem, and thank goodness, because considering this is only the second half and this is already like going on 40 minutes, this is a ridiculously long video. Anyway, imagine that a balloon is inflated so that the surface area is multiplied by 9. Okay, what happens to the circumference, and how does the volume change? Okay, here's what you need to focus on. It says surface area, but what matters is area. Okay, the area is multiplied by 9. Now this says circumference, but what matters is that that is a length. Okay, so we're messing with the area, and then I'm asking you, how does the length change and how does the volume change? It doesn't matter whether it's circumference or diameter or length. They're all lengths. Okay, so let's remember how we do this. I feel like it's useful to draw little pictures to remind us that let's see, let's say if we have a this cube will represent our volume, and we will use a square to represent our area. Whoa, I missed. Okay, this square will represent our area, and this little segment here is going to represent our length. You messed up a little bit, but that's okay. Okay, so it's all about length, area, and volume, and how changing one changes everything. What I suggested to my students, which is probably you, let's be honest, in class is that imagine that the original length was 1. Okay, it doesn't matter what it was because the changes always work the same way. If the original length was 1, then my square would be a 1 by 1 square, so my area would be 1. So this is length, and this is area, and this is volume. Okay? So if my length is 1, then this would be 1 by 1 by 1. So my volume would also be 1. So let me get this straight. Let me make this very clear to you. If you imagine that if you imagine 3 original shapes that had dimensions of 1, the length would be 1, the area would be 1, and the volume would also be 1. So now, if we find out what happens as we change these values, and it'll be the same thing no matter what the original lengths really were. Let me show you what I mean. It says that the area is multiplied by 9. So that means, boom, instead of being 1, my new area is 9. Alright, because I had to multiply 1 by 9. Now, if this area is multiplied by 9, then that's going to change the lengths here. Okay, because in order for the area to be 9, the lengths must be 3 by 3. Okay, but these dimensions should be the same. This piece and this piece should be the same. So that means the lengths, even though the area was multiplied by 9, the length went from being 1 to 3. So the length was just multiplied by 3. And if I know that this is 3, then that means all these dimensions are 3. But what will that make the volume? Alright, it's 3 times 3 times 3, so that's 27. Okay, so the area here in the middle was multiplied by 9. But that meant that the length was multiplied by 3, and the volume is actually multiplied by 27. Because remember, everything started off as 1, so the length went from 1 to 3, and the volume went from 1 to 27. So how does the circumference change? Well, the circumference is just the length, and the lengths were multiplied by 3. So multiplied by 3. How does the volume change? The volume was multiplied by 27. Longest video in history, people. And I just did this one problem because this was a review, and we've obviously did many problems. But if you needed more practice on this business of how changing the area changes the length and the volume, or vice versa, I have a whole video just on this. So I mean, this is day 8, so I'm pretty sure if you look back at like at day 5 or day 6, I think it's day 6, you will find a whole lesson about just this if you need more practice. Alright, I hope this has been helpful. If so, go ahead and give me a thumbs up. Show me that you appreciate what I do, and I can keep on doing it for you. In the meantime, I will see you on the next video.